Hi guys, welcome to lecture 107 on the limit definition of the derivative. I'm hoping you look at this and you say, wait, I've seen this, because in fact this was handout 2 from Unit 10 last May. So the question is, how do we determine that the slope of the tangent line at the point 1, 1 is in fact 2? Step 1, pick a second point on the parabola. We end up with algebra that's more manageable if we call the second point 1 plus h. That is to say that this delta x from here to here is equal to h, and the y-coordinate then becomes 1 plus h quantity squared because we're on the parabola x squared. So we're going to use the regular slope formula to write an expression for the slope of the line between these 2 points. You're then going to simplify this slope as much as possible. If you want to give the algebra a try, you may just pause the video and restart. And a reminder that the ordinary slope formula is the change in y over the change in x. So my delta y is my higher y point, 1 plus h quantity squared, minus 1 plus h, minus 1, which was this point here. And then my change in y was 1 plus h minus 1. Finally, the tangent line slope is the limit of this expression as h approaches 0. So you should get the correct tangent line slope, or the correct slope of the tangent line. And after all our work, we know how to evaluate this limit. There's no problem here, so we can simply plug in 0, and we see that that is the slope of the line, tangent to the curve at the point 1, 1. So we can now find the slope of the tangent line at any point on the parabola. So call the first point x comma x squared, and the second moving point is x plus h comma quantity x plus h squared, as is shown before. So just as we did before, we'll write an expression for the slope of the line between these points. And then I will, so pause the video and push play when you are ready to check your answer against mine. So I start off with x plus h squared, sorry, the squared's a little illegible, minus x squared over x plus h minus x. I multiply out my numerator, subtract my common terms, and I've simplified the denominator to an h. I factor out an h, and I divide it out, and then I'm left with 2x plus h. Now since we want the slope of the tangent line, so the line touching only at this one point, right here, we want this delta x right here, this change in x, to go to 0. So we want these 2 points to be getting closer and closer together. So we're going to take that limit. That's what this statement is saying. And we know how to evaluate that limit, and that limit is 2x, i.e. there's no problem plugging in 0 for h. Now we're going to perform the same steps to find the derivative of the function y equals x cubed. So I've given you the steps, 1, 2, and 3. So I will fill them in one at a time, in general, not completely, and pause in between if you want to try it yourself. Step 1, set up the slope formula with our x plus h cubed minus x cubed over x plus h minus x, and you should simplify it. Expanding this is not much fun. You might use Pascal's triangle. You might remember how to expand a cube. Simplifying to that. Now take the limit of that expression as h approaches 0. And note that this is what that statement looks like in math. So the derivative of y equals x cubed is 3x squared. Question 3 is saying, at the point 2, 8, what is the slope of the line tangent to the graph? Well, that means we have a y value of 2, so 3 times 2 squared equals 3 times 4 is 12. So the slope of the line tangent to the graph at 2, 8 is 12, i.e. a very steep line. So, in summary, the limit definition of the derivative comes from the slope formula, and it is as such. The limit as h approaches 0 of f of x plus h minus f of x over h. And remember that the h comes from the delta x, which is x plus h, minus x, which just equals h. So all the work that you've done on evaluating limits is simply to help you evaluate a very special limit, that is the limit definition of the derivative, to find the derivative. It does require some fancy footwork algebra. Even though you know the derivative rules, those rules only are applicable when the directions don't specify how to find the derivative. So as long as you see, using the limit definition of the derivative, find blah blah blah, you're going to want to make sure you can evaluate the limit like this. That's all for tonight. Have a good evening and sayonara.